Year 11, homework 9. What we're going to do in this one is mainly a revision of the very important topic 1 from year 10. If you remember, it crops up on both paper 1 and paper 2 of that Excel specification. So it's really important that we know about this. It starts off, there are 3 naturally occurring isotopes of oxygen. Oxygen 16, 17 and 18 give the electronic structure configuration, the electronic configuration of oxygen. Okay, so this question is designed to confuse you, of course. Remember, it's possible to have different atoms of the same element. When it's written like this, this means oxygen with a mass number of 16, oxygen with a mass number of 17, oxygen with a mass number of 18. This isn't a minus here, this is a mass number. So it's possible to have 3 different isotopes of oxygen, 3 different atoms of oxygen. The important thing to remember, of course, is that oxygen is oxygen because it has an atomic number, a proton number, if you like, of 8, which means it has 8 protons in the nucleus. Now, all atoms of all elements are electrically neutral. So if they have 8 protons, they have 8 positive charges. 2, 3, 4, 5, 6, 7, 8. So if they have 8 positive charges, they must have 8 negative charges. 3, 4, 5, 6, 7, 8 to balance each of those positives out. Now the particle that is negatively charged is the electron. So the electronic structure or configuration has nothing at all to do with the mass number. It's all to do with the atomic number, which you can find on the periodic table, of course, at the back of your book. Okay, 2 electrons on the first shell, 6 on the second, so you can write it like that, 2.6 or 2:6. Draw a diagram showing the electronic structure of the oxygen molecule. Now remember the O2 molecule is O2, like so. So if we're going to draw it out, we're going to have 2 electrons on the first shell and 6 electrons on the second shell. Now, in the molecule, every atom has a full outer shell of electrons. This doesn't have a full outer shell. So ask yourself the question, how many electrons does it need to get a full outer shell? Answer, 2 more. 2 more, it needs 2 more. So in which case, if it's getting the oxygen molecule, it's 2 oxygen atoms, 2 non-metals. Non-metal bonding only is called covalent bonding. Now the definition of a covalent bond is a shared pair of electrons. Now an atom will share as many pairs as it needs electrons. Now the only thing we're working with here is 2 oxygen atoms. So this needs 2 electrons, so it's going to share 2 pairs. And it's going to share 2 pairs with only 1 other atom. So this second atom, we need to draw it over 2 of those electrons. So I've drawn the outer shell, okay? And it actually says outer electrons only, so I can probably scribble that inside shell out there. So can you draw me the outer shell of this second oxygen atom? And this second oxygen atom is also going to have 6 electrons in it. You need to put 6 electrons around that to ensure both have a full outer shell of electrons at the end. Now remember, a covalent bond is a shared pair of electrons. Okay, so this is going to have 6 electrons in its outer shell, so it's going to need to share 2 pairs of electrons. Put them on there. So what's an isotope? You just need to look that up in the glossary. Okay, look at the glossary of any book you've had from me, either year 10 or year 11, and have isotope in it. It'll tell you there's 2 or more atoms of the same element, and you need to finish that off now. Look in the glossary. Oxygen has an atomic number of 8. What is the atomic number? I've already told you, haven't I? The atomic number is the number of protons in the nucleus. Okay, so now we've got the composition of the nuclei. Give the composition of the nuclei of the oxygen isotopes below. Well, the nuclei is the protons and neutrons. I don't know why I've put electrons on there. We'll do electrons as well, but of course electrons aren't in the nuclei. I shall need to change that, but it may not be in the version of the book that you have. Okay, so oxygen 16. Well, if it's got 16, well, let's not do that. Oxygen, I'm going to do carbon 12, and I'm going to do carbon 14. Okay, if we look at carbon 12 and carbon 14, they've both got atomic numbers of 6, because of course they're the same element. That means they've got 6 protons and 6 electrons. Okay, the mass number we get from taking the atomic number from the mass number, and this works because electrons are virtually weightless, virtually without mass. So this top number here is the total number of protons and neutrons. If that's the number of protons, okay, all we need to do is take the protons away from that top number, and what are we left with? Just neutrons. 12 minus 6 is 6. So that there would be 6 neutrons. And in carbon 14, 14 minus 6 will be 8 neutrons. you need to do that for those ones now. Okay, next question. Okay, now we've got to do the same thing. What would be the number of protons, neutrons, and electrons in the oxygen ion? Okay, all right. We'll tell you what, I'm going to do the lithium ion. I'll do the lithium ion. Lithium ion is Li+, so it's similar but different. Okay, now if I look at the atomic number and the mass number of those, they are 7 and 3. 7 is the mass number and 3 is the atomic number. Now, it doesn't matter, okay, it doesn't matter what happens to the charge. The atomic number is never going to change because that's the number of protons in the nucleus and that never changes. Okay, so if I look at the lithium atom is 7,3. That would have 3 protons. Well, over here, it also has 3 protons. It doesn't matter that the charge has changed, it still has 3 protons. Okay, now in the atom, is it electrically neutral, so it has 3 electrons. This, however, is not electrically neutral. This is positively charged. So let's think about that. 3 protons, yeah? How many electrons must it have to leave 1 positive charge left over? Well, let's go look at the atom again. Okay, 3 protons. This had 3 electrons to cancel each and every one of those out, yes, to make it neutral. Okay, well here, how many electrons does it have? That electron there cancels that out, so that would be 2 positives left over. There's another electron, cancels that one out, and now we've got 1 positive left over. And that 1 positive left over is that positive there. So in the lithium ion, it has 2 electrons. So here, the number of electrons is going to be different to whatever you thought it was over here, because these are elements and neutral, and this is an ion and charge. Now the neutrons, bottom number minus top number, doesn't matter which one it is. 7 minus 3 equals 4 neutrons. Whether it's the ion or the atom, it's going to be 4 neutrons. Okay, because they're in the nucleus as well, and that doesn't change. Ions have only gained or lost electrons. Okay, so it's the electrons that will be different in the ion. This will have a different number of electrons. Oxygen can bond with many metals. What type of bonding will this be? Well, a metal and a non-metal bond is ionic. Metal only is metallic, and non-metal only, as this example here, is covalent. Covalent shared pair of electrons, not charged. The molecule's not charged at the end. When we do ionic, okay, it's metal giving electrons to non-metal and they end up charged. Okay, explain how magnesium bonds with oxygen. Well, I'm not going to do magnesium with oxygen. What shall I do? I'll do lithium with oxygen, shall I? Oh, no, I don't know. I'll tell you what, I'm going to do lithium with fluorine. So you can have a different one. Lithium with fluorine, okay? Now, to do this, I could explain or I could draw a diagram. I'm going to draw a diagram. So I'm going to look at the periodic table and find lithium has an atomic number of 3 and fluorine has an atomic number of 9. Okay, I'll give you magnesium's atomic number. That's going to be, in case you can't find it, it's 12. Oxygen is 8. Okay, so I'm going to do this one. Okay, I'm not doing those. Don't copy this for your homework. So I'm going to draw lithium. Lithium's got a dot for the nucleus, 2 electrons on the first shell, 1 electron on the second shell. Fluorine, 2 electrons on the first shell, 7 on the second shell. Now remember, atoms join together to form compounds to get a full outer shell of electrons. Lithium here can either gain 7 to fill that shell or lose 1, because once it's lost that one, that shell doesn't exist. The inner shell is the outer shell, and that is full. That's going to lose an electron. Fluorine is going to gain an electron. So I have an arrow, because I'm explaining, my arrow starts at the electron, finishes at the gap, and I'm going to label it E minus transfer. There's a minus there. Minus transfer. Okay? Now, that's not the whole story, of course, because now this electron is charged. We've gone from being neutral atoms to charged ions. Now, this is another reason we label this arrow E minus transfer. This minus is transferring over here, so this is therefore going to be F minus. If that's F minus, this has to be Li plus. And these oppositely charged ions stick together. So really, it's not an ionic bond, it's an ionic attraction, because the positive ion attracts the negative ion. Opposites attract. Okay. Give the formula when compounds are produced when oxygen bonds with lithium, calcium, and iron. Okay, so to do this, you need to know charges on ions. Okay, the periodic table tells us the charges on metal ions. Okay, for anything in group 1, 2, or 3. For example, if it's in group 1, okay, all these are in group 1, they have 1 electron on their outer shell, they want to lose 1 electron, they have a single positive charge. So I'm going to take potassium as my example. Okay, so I'm not going to do these. Okay, I'm going to do different ones. You can look at what they are. So I'm doing potassium. That's going to be K+. Okay, and I'm going to do it with, what shall I do it with? I'll do it with sulfur. Okay, sulfur is in group 6. Sulfur's in group 6. Anything in group 6 is going to want to gain 2 electrons. So we've got 6 electrons on their outer shell because they're in group 6. Therefore, they want to gain 2 electrons to get a full outer shell. So anything in this group is going to form the 2- ion. So I'm going to say potassium sulfide is K plus S2-. Now, to come up with the formula, these have to balance out. So ask yourself a couple of questions. Are these charges the same? Answer, no. If they were the same, the formula would be Ks. It would simply be Ks. They would just be like that, Ks, okay? But they're not the same, so it's not that, okay? So next question, which is the more of? Answer, there's more negative. So what do we need more of? What do we need more of to make them balance? Answer, we need more positive. How many more positives do we need? Well, we just need another positive, don't we? We need another positive. So I've now got 1 positive, 2 positives to balance those 2 negatives. So what we now need to do is count all these. 1, 2 positives. So that's going to be K2. I've got 2 Ks. 1s, K2s. Okay? Calcium. I'm not doing calcium. What shall I do? I'll do magnesium. Magnesium is in group 2. Okay, magnesium is in group 2. So I'll do magnesium. Again with sulfur. Why not with sulfur? Okay, so now I've got Mg2+, because it's in group 2. It's got 2 electrons in its outer shell. Okay, so it must form the 2+ ion, S2-. First question, are these charges the same? In this case, they are. I've got 2 positive and 2 negatives. So these charges are now balanced. So the formula is just going to be Mgs there. Okay? Now, where's a Roman numeral after it? Where's a Roman numeral after it? I'll help you with this one. That tells you the charge on the ion. So basically, iron is in this middle group here. Now, these elements here can form ions of different charges. We don't know what they are. That's why it tells us. So where it says iron 3 like that, that means it's iron 3+, Fe3+. Okay? So you have a go at telling me the formula of that. That's much harder. Finally, we've got empirical formula. Now, we did empirical formula in the last homework, so there's a video there about that. They are quite crucial calculations, so what I'm going to do, I'm just going to go back to the year 10 book. Here's the year 10 book here. Okay, I'm not going to do that one. Okay, you are going to do that one. I'm going to do this one here, number 11, okay, in your year 10 book. Okay, it says, let's just move that down so we can see it. A compound of iron and oxygen contains 1.12 grams of iron and 0.64 grams of oxygen. Okay, what you need to do this, you divide your page in half. You write moles equals mass over atomic mass on that side. You write moles equals mass divided by atomic mass on that side. Do it this way, you will never get it wrong. Okay, on one side, we write iron, or whatever you have got in your question. We've got iron here. In the last homework, it said X. We'll write X there. And we've got 0.64 grams of oxygen, so we're going to write oxygen on this side. And the last homework it said Y, so we'd write Y here. Whatever it says, I mean, in your homework this time it's got aluminium and chlorine. Right, so we need to identify the mass. There it is. We know it's a mass because it's got a unit after it, 1.12 grams of iron. And now the atomic mass of iron is found on the periodic table, it's 56. Okay, and that's what we do there. On the oxygen, it's 0.64 grams of oxygen, 0.64 divided by 16, because that's the atomic mass of oxygen. Stick those two into a calculator. Okay, stick those two into a calculator. We'll start with this, 1.12 divided by 56 equals 0.02. And over this side, we've got 0.64 divided by 16 equals 0.04. Okay, so our empirical formula at the end, therefore, is going to be iron, Fe, 0.02, oxygen, O, 0.04. Now, we need to report this to the smallest possible whole number. Okay, so that's not quite the final answer. Okay, we just need to report this to the smallest possible whole number. To do that, ask yourself a couple of questions. Are these numbers the same? If they are, the answer will be FeO. They're not the same, so it's not FeO, because they're different. Second question, okay, which is bigger? Answer, the oxygen is bigger. So the final answer has to have a number next to oxygen that is bigger than the number next to iron. Okay, that's important. Final question, how much bigger is it? How much bigger is it? Well, looking at those two numbers, I can just see that number there is twice as big as that number there. If you can't see it, then take the big number, which in this case is 0.04, and divide it by the little number, 0.02, and it tells you it's twice as big, equals 2. So the final answer, therefore, is going to be FeO2, because the oxygen is bigger, we've decided that already, and it's twice as big by dividing the big number by the little number. Okay, good luck with that one. Right. So, is that the end of that homework? Where did we get to? That was the end of that homework, wasn't it? Yes. So, with this one, you're doing aluminium chloride. I'll give you the atomic numbers. AR of aluminium is 27. You can find it on the periodic table if ever you don't know it, and chlorine is 35.5. You now have all the information to do all those questions.